Alright, solve exponential equations without logarithms. Now, when it comes to solving exponential equations, there's something that we must have in order for us to be able to solve them without logarithms. Now, some of y'all have done logarithms before. Most of you have not. So we're getting there. That's coming down the road. But right now, we're going to solve these basic exponential equations without logarithms. Alright, here's the thing. If the bases are the same, then the exponents are going to be equal. We're going to see that rule written out formally in just a minute. Notice how both of my bases are b's. Alright? Base, b for base. Which means the exponents have to be equal. So when we solve it, what we're going to do is we're going to go ahead and cancel out the bases. Whoops. Imagine they're not even there. And just solve the equation with the exponents. So x equals 1. So write that down. So we need to have a common base. We don't have a common base. But when you look at the base 2, that can't get any simpler. You can't break down a base of 2, if it's already a base of 2, into some smaller number. 2 is a prime number, right? But if we look over at 4, we can convert 4 to also having a base of 2. What would 4 be with a base of 2? 2 to the what exponent? 2 squared. So I'm going to rewrite the 4 as 2 squared. Now we have the same base. The base of 2. So I'm going to cancel those bases. And then the exponents are going to be equal. So x plus 8 equals 2. So subtract 8 from each side. So x equals negative 6.
And that's it.
Very simple. So you're looking for that common base. In many cases, our common base is going to be a prime base. Something like a 3, a 5, a 2, a 7. Sometimes you can use bases that are not prime, and it works out just fine. But we need to have a common base. It's got to be a common base if you're not going to use logarithms. Let's go to the next slide. Copy this down. Okay, so this problem looks a little different. It's a 1 with no exponent equal to a base with an exponent. So, let me ask you this. What happens when I take a number to the 0 exponent? What do I get?
0.
1. Does it matter what the base is if the exponent is 0? Nope. So, if I want a common base in this problem, what can I convert that 1 to be? What expression? Something with a base of, with an exponent of 0, right?
8.
How about 8 with an exponent of 0?
So bad.
Okay, so if you're equal to 1, you can always convert that 1 to whatever base that you want or need, as long as the exponent is 0, because anything to the 0 is 1. So now I don't need a prime base because I've got common base already. So I'm going to cancel those 8's. That's going to be 0 equals 3n plus 1. Subtract 1. So then negative 1 equals 3n. Divide by 3. N equals negative 1/3. There it is. Okay? Okay, so here we've got one where we have different bases. We don't have a common base. Neither one of these bases is prime. But I bet there is a prime base that we can use for these. What do you think it might be? 8. 8, that's a good guess, but is 8 prime? And can I convert 16 to a base of 8? In other words, is 8 to some exponent equal to 16?
4.
All right, can I do 4 to an exponent to get 8?
No.
2.
2. 2. All right, now, 2 is the base. 2 to the what is 16? 2 to the 4. So that's the 16 part, but I still have the x plus 1. So I have to multiply by x plus 1 up there. Alright, over here, 2 to the what equals 8? 2 to the third. And then multiply by 3x minus 5. So I can now cancel my bases, because they are the same. I've taken care of the exponents. Just simplify by distribution. Well, not FOIL it, but distribute. 4x plus 4 equals 9x minus 15.
Hold up now. Hold up.
See what we did?
Oh, you multiplied.
Multiply. Okay.
Subtract the 4 from both sides.
So now solve by subtraction. Okay. 4x. So 4 equals 5x minus 15. Add 15. Y'all know how to do this mess. 19 equals 5x.
Man, God. That's what I got a box.
Wait. Hold on. Don't
I
erase
was gonna be
nothing.
20.
Whoa.
Not now.
Okay. So 19 over 5 is the answer. All right, take a look at this one. Okay, copy that one down. Okay, so in this problem, again, we do not have a common base, but 27 and 81 can be converted to a common base. What do you think it would be? 3. So 3 raised to what exponent is 27? 3. And you still have that x there. All right, and then 3 to the what is 81? 4th. And you still have to multiply by the 2x minus 1. It doesn't go away. All right, so now we can cancel bases. 3x equals 8x minus 4. Let's move the x to the left side, so minus 8x. Be careful with your signs. Negative 5x is negative 4 divided by negative 5. X equals 4 fifths.
Okay, I subtract 3 and I still got the same.
You can. So, the property of equality for exponential functions is the rule that allows us to do what we've been doing. The formal phrase or formal rule is, suppose b is a positive number other than 1, then b to the x equals b to the y if and only if x equals y. And that if and only if statement is very common in math. It is very important. It says that if I'm proving this theorem or this property in a mathematical proof, I would have to prove 2 things. First, I would have to prove that if b to the x equals b to the y, then x equals y. And I would also have to prove it the other way, the converse, which says that if x equals y, then b to the x is also equal to b to the y. So I would have to prove it both ways. That's not something we have to worry about in this class, but that's the way it works in mathematical stuff. All right. Okay, so here we've got 6 to the 2x minus 1 equals 1 over 216. Now, we need a common base, but can I convert a base of 6 to a base of 2 or 3 or 4 or 5? No, so there's no number less than 6 that I can make, that I can simplify the base of 6 to. So that's not going to work. So I need to have a base of 6. Can I convert 216 to a base of 6? Yeah, what would it be? 6 to the what?
6.
Nope. 6 times 6 times 6. 6 to the third. So I'm going to mark that out and put 6 cubed there. Now, I don't want the 6 cubed to be in the denominator. I need to use the negative exponent property to get that base 6 up into the numerator, basically. So what am I going to do? 6 to the negative 3. So let me rewrite that. 6 to the 2x minus 1 equals 6 to the negative 3. Very good. All right. Now we do have a common base. What can we do with it?
They can cancel out.
Cancel them. That leaves 2x minus 1 equals negative 3. Now it's the basic equation. There you go. Okay, so this was a little different in that you had a fraction we had to flip. Yes?
Why would you put the negative, like, after that to flip it over?
All right, if I have, remember the negative exponent property works two ways. So if I have 6 to the negative 3, that's going to flip that to 1 over 6 cubed, right? Or if it was starting in the denominator, I would flip it up to the numerator, if you will, and change the sign. Okay? So it works both ways. I just needed it to be in this form instead of this form because this had a base of 6. All right? So it's just something we needed to do in that case. See if we got another one. Okay, let me delete some of this so we can work it. Alright, so you can see what we have here. 1 over 9 to the x equals 81 to the x plus 4. What do you think our base is going to be?
3.
You could use 3.
9.
Or you could use 9. Now 9 is not a prime number, but it will work. It'll create less work for us if we use 9. Because you can convert 81 to a base of 9. So what is 81 to a base of 9? 9 squared. So you got 9 squared. And then multiply by x plus 4. And then over here on the left, you need to convert that 1 over 9 to the x to be what?
Negative 9x.
Not negative 9x.
I mean,
9
negative x.
9 to the negative x. Remember, you flip it, change the sign of the exponent. Okay, so now we can cancel bases. Negative x equals 2x plus 8. So now it's just a simple equation. Subtract 2x.
Negative 3x plus 18.
And there you have it. All right, so again, when you have powers with a common base, go ahead and add those exponents. You can go ahead and cancel the bases if they're the same, and solve. And we got m equals 0. Now look over at number 10. This one is dividing powers with a common base. So what do you do with the exponents when you divide powers with a common base? Subtract them. So what's x minus x? 0 equals negative 2x. You can cancel those bases. Now divide by negative 2. So x equals 0 again. Okay, so again, if the bases are the same and you're multiplying, you add the exponents. If the bases are the same and you're dividing, then you subtract the exponents. So turn the page over. It'd be negative 2x plus 1 plus negative 2x minus 3 equals negative x.
And once you do it, like, don't you do the negative 2 plus negative 3?
Yes.
Oh, that's negative 4.
Yes.
Ah, my bad.
All right, turn it over. All right, let's take a look at number 21. All right, in number 21, notice I've got a 6 here. I've got a 216 and a 216. Well, what do you think the common base is going to be? 6. We saw that earlier. But we don't want 1/6. We want it to be 6 to the what? What do you do?
6 to the
Negative third.
6 to the
6 to 0.
6 to the negative.
3x minus 2.
Well, yes, but what can I convert this 1/6 to? Real quick.
6 to negative
6 to the negative 1. So let's do that. 6 to the negative 1 times 3x plus 2. And then 216 is what? 6 to the what? Third. So times 6 to the 3 times 3x equals 6 to the what? Negative 3. We saw that earlier. So now I've got common base. I can cancel those bases, but remember, look, you might want to go ahead and multiply this negative 1. So that'd be negative 3x minus 2, and this would be 9x. So what am I going to do with those?
Add them together.
Add them. So go ahead and put a plus there. So you're going to have
6x.
6x minus 2.
equals -3. So you can solve that. I'm not going to solve it. You can do that. All right, so there you go. So you just got to be careful. You got to make sure you get a common base. You got to use the rules of exponents. The thing about this stuff is it uses all of the things that we've learned about exponential rules and properties in order to solve these equations. You see how the further you go in math, you just use everything that you've used before, everything that you've learned. It never goes away. All right, so this is what you're going to do for your assignment. You're going to do the evens, and you're going to do 6, 12, and 22 for ticket out the door. 6, 12, and 22 for the ticket out the door. You're going to do all of the evens, though.
On both sides?
On both sides, yes. So you can go ahead and get started. Look, this is for a grade. This ticket out the door stuff is for a daily assignment. So when you finish, come show me.